Hello, programming languages students. Welcome back for another Prolog tutorial. For this one, we're doing another example with lists. Sort of, there's probably four, um, yeah, I'd say four basic concepts, basic patterns that show up when writing list predicates. And so we've talked about a couple of them. We've done member, we did A to B. This is another one. This is to get how to get a length of a list. And you'll notice that all these are really specific predicates that do really specific things, but the patterns in them will show up in a lot of other list manipulation you do. So these are all really good starter ones. Um, sort of like in Java, when you start with max, min, sum, count, the number, so that there are certain patterns that show up in arrays, um, just like there are certain patterns that show up in lists here. So we want to find the length of a list. And so given a list, maybe we'll call this len. Given a list, we would like to be able to find its length. So in this case, if we give it a list, we would have list as input, and then x, this variable, is our output, which should give us the length of our list. Now note, we should also be able to verify the length. If I put a 5 here, it should work. And if I put some other number, it should not work. Right? So we should be able to verify the length of a list or find the length of a list. So to write this, as with all Prolog recursive predicates, we're going to have two parts, or more, two or more parts. But regardless, the first part is always going to be our base case. What is the simplest possible solution to this? Well, when we think about finding the length of a list, what is the easiest list to find the length of? Well, an empty list. So if we wanted to find the length of an empty list, what is it? Well, it's 0. So that's pretty easy. That's our base case here. So then the next question is, what do we do with the rest of our lists? What do we do with a longer list? So if you're starting to feel comfortable, you can take a minute to pause the video, give your own attempt at this. But I think I will go ahead and dive in. So if you want to pause it, pause it. If not, here we go. So the first thing is we want to take this list, and as is very frequently the case, we probably want to split it into its head and tail. Not always the case, but frequently the case. And so we split the list into a head and tail, and then we need some number that we're counting. This should ultimately be the length of our list. And so let's use n here. So we're going to take the length of a list that we split into a head and a tail, and an n that is a number. Now, one step that is hopefully pretty clear is that we're going to need to recursively enter again, where we put the tail of the list in, and then we need some other variable, right? So the idea is through each iteration of this recursive function, the higher iteration, the earlier iteration, is going to be a larger number, and this iteration should be one lower. So as we break one piece of the list off at a time, we are basically counting off that piece. And so as we count, we're going to need a different variable to track how large the smaller list is, right? So the idea is, well, we'll walk through an example in a second. So we want the length of the tail of the list and some x variable, and the key here is the relationship between this n and this x. So if we have a list, we split it into a head and a tail, we pass the tail back in, then the count or the length of this list, the tail of the list, should be one less than the count or the length of the list with the head and tail put together, as they are here. So in other words, x should be one less than n, or n should be one more than x. Let's do n equals x plus 1. So n should be one more than x. The length of this list is one more than the length of this list because it has the head of the list added on. Now, quick note here, this is going to cause a problem. This is a good reminder, refresher. Remember, when we're working with numbers, we see a plus sign, a minus, a times, a divided by. What should that immediately click in your brain in Prolog? Use is instead of equals. Equals will literally take this expression and unify it. We don't want the expression, we want the actual math done. We want x plus 1 to happen, and then assign that value to n. So we're going to use is. So this is the relationship. This will work. Before we run it, there's a little problem here. This h, this variable only appears once. This is another example where we don't actually care what's in the list, right? So if we're counting how many elements are on the list, we don't care what each element is. We simply care that we remove one element and count it. So in other words, we don't care what the head of the list is as we decrease the size. And so we'll use an anonymous variable here, throw away the head of the list. We don't care. We just want to, the important part is this relationship, this counting from x to x plus 1, which is the list with a head on it, right? So this has one element, one extra element added to the list. So this works, and I'll show you that it works. If I use a variable, the length of this list is 5. If I use 5, I get true. If I use any other number, I get false. So this is now behaving as intended. So let's do a recursive example here, and let's make sure it makes sense. And we'll start with actually putting all the numbers in. So length of a comma b and 2, and this is true. So let's walk through the pattern with the recursive function here. So we tried len of a comma b and 2. Obviously, it does not match this pattern. It's not an empty list and it's not 0. So instead, we go to this pattern. So the first iteration, we take our list of a comma b and we split it into its head and its tail, which is now the list b. So that is passed into our length predicate. We're trying to find the len of this, and then n is 2. Right? So the only thing we've done is I've taken our list, which was originally a comma b, and split it into its head, which is a, and then its tail, which is a list version of b. All right? So this is true if len of t comma x is true. Well, len of t comma x, that means that we need to iterate again. And we don't actually know what this x is yet. We don't know whether this is true or not. So we're going to loop back up and check this. Note that we have not reached this extra condition yet. We're going to just run our recursive function first. So we call len of t and x. Well, t is this list with just the list version, a list that just contains the letter b. And so the first predicate, our base case, is not true. This is not an empty list yet. So we run again with len of b and empty list. Whoops, vertical bar, empty list. All right, so we split the list b into its head, which is b, and its tail, which is an empty list. And we have a number, but we don't know what that number is. That's going to be x from first iteration. All right, that's the value that's ultimately passed in here. We're not sure what it is yet. And so this is true if len of t comma x is true, and some other stuff that we'll deal with in a little bit. This n equals x plus 1. Yeah, so by the way, one note here. This x from the first iteration is unified with n in this iteration. I should mention that. So these are unified because this x value is passed into the next iteration. So x and n are unified. They're considered the same value here. I'm going to make more space. As we go into our third iteration. Now in our third iteration, what is the tail here? What is the value passed into the len call again? Well, the tail is now an empty list. So we have len of empty list, comma, and then what? Well, when we go in here, we have an x. We're not sure what this x value is going to be yet. It hasn't been defined. We haven't actually reached this statement yet, so we're not doing any of this math yet. But what we find is that we have a match. So len of empty list. This first initial predicate now matches. with a value of 0. So this value of 0 is now going to propagate its way back up through our recursive calls. So this 0 is now unified with x. And now that 0 is unified with x, we know that the tail was an empty list, right? We took the tail of this list is now an empty list. This was unified with x, so x equals 0. Now we get to check our second condition on this iteration. So n is x plus 1. N is 1, right? X equals 0, therefore n is 1. So n is unified with the value 1. So that means the n from this second iteration is unified with 1, which means that x from the first iteration must unify with 1. And you'll notice that each iteration, these x and n have their own, we're tracing back our own x's and n's from each iteration. So our x from the first iteration is unified with n from the second iteration, which is now unified with 1 as we've crawled our way back up, which means that when I go back up here, x is then unified with 1, which means that the only way for this to be true is if n is x plus 1. Well, if x is 1, this would mean n needs to unify with 2, and fortunately for us, we put in the correct number here. So all of this checks out, all of this unifies, and that's why we get true. And so our base case checked out. Now, in theory, once we got true, we should keep checking, except that once we've gotten this true statement, that all the way, once we've iterated all the way through, we found this base case, this predicate can't even run because we have an empty list, and you cannot split an empty list into a head and a tail. So nothing else runs, we're done. We have verified that when the length is 2, as long as we iterate down and get to 0, on the way back up, we count and say that, yeah, the length is 2, and you gave us 2, so this is true. Similar process if you give it a variable. It'll come back up and tell you what that variable should be. So this is verifying that the variable or the number you gave it is correct. If you give it a variable, it'll go through the same exact process, come to this 0, the 0 will become a 1, the 1 will become a 2, and then here, instead of just this being a 2 to verify, this is a variable. And so this would end up just printing out that it has to be 2. N has to be 2. I guess this should be an n. N must be 2. And if I put it in here, that means x must be 2. So hopefully that makes sense. Again, it's really tough to start picking up on recursion. It's not the way people naturally think. But I think this example helps, and I think a lot of other examples, a lot of this is just practicing and doing more and more recursion practice. So I'll talk to you next time.